Around 6.3 millions of the women were diagnosed for the breast cancer, and 670,000 women were died globally in particular 2022 according to WHO. So how much do we know about the breast cancer? For that reason, I have done this Haberman Breast Cancer exploratory data analysis. So to figure out what's the key insights or whatever the pattern that I found in this particular data set. For that, I have to deep dive into the presentation. Let's explore to find the hidden patterns in the data set together. We have data set of around 306 patients, and the study that conducted on the survival of patients who had undergone a breast cancer operation in the University of Chicago Billings Hospital during the year of 1958 to 1970. So before diving into the presentation, so first let's discuss what is breast cancer. Normally the cell that grows get the information from their DNA that at which rate they have to grow. But the abnormal cell grows out of the control and form tumor, and that cell converts into the cancerous cell, and if it's in the region of breast or armpit or sometime under the neck also, that we can say breast cancer. So we have data set overview and we have 306 patients, and we have different factors that we are considering there, like age is the first factor, year and nodes, and the last survival status. So what is the age? Age is the patient age. Here we can say the operational year at that time, like from 1958 to 1970. And if we talk about nodes, so number of nodes means the positive auxiliary nodes that present in the patient. We have two survival status. First one is status 1 and second is status 2. That means if the patient is survived for 5 years or longer, or second one is that is not survived under the 5 year. Okay. Let's dive into the survival analysis. Like we have different patients, around 306 patients, and out of that 225 successfully survived and 81 didn't survive. If we see in the donut chart, so 73.5% all the patients are survived successfully, but 26.5% also didn't survive due to the several factors that we discussed in our video and in our presentation, that what are the factors that influences that patient that they are unfortunately not survived. So in terms of percentage, as I told, like 73.5% survive and 26.5% of the patients are not survived. So we have three types of analysis here: age-wise analysis, year-wise analysis, and node-wise analysis. Because we have different patients, and in that patient, the youngest patient we have is around 30 years, and the oldest patient we have is around 83 years. And in this age bracket from 30 to 83, we have different number of patients. Sometimes, or for some age bracket, the number of patients are higher, and for some age bracket, the number of patients are lower. We can see from this bar graph clearly, like around 50 to 55 age bracket, the number of patients are very much higher as compared to the other age bracket. If I talk about 50 to 55, in this age bracket, around 18.3% of the total patients are lie or under this age bracket. So that shows the impact of the age. So first, our patient whose age is 40 or less than 40. So we have 43 out of 306 patients that comes under this age group, like 40 or less than 40, and I have considered nodes with the age also, like 40 age or less than that with 5 nodes or less. So we have 33 patients out of 306, and in that 31 is survived and 2 is not survived unfortunately. So here we can conclude like 10% of the patient whose age is 40 or less with the lymph node of 5 or less have survived successfully, which is almost 94% of their total. So this is a very good key insights that we derive from here, that we gather from here. If you have a patient whose age is 40 or less, or that have a lymph node 5 or less, so the chances of their survival is much more higher than the other age group or the other number of lymph nodes. So till now I talked about the patient who survived, but there are some patients, and around 81 out of 306 patients that are not survived, I did the histogram presentation also to show that what's the impact of the age on their survival. So in this histogram, we can see distribution of plot by age parameter. Upper part of the histogram shows that status 1 means that patient is survived, and the below part of this histogram, the status 2 is showing like that patient is not survived. So we can see like in the age from 30 to 40, only 4 patients are survived. So that shows like if a patient have a age below 40, as we saw previously in the previous slide also, like if the patient have the age below 40, so their survival rate is higher or their mortality rate is lower as compared to the other age group. Out of 81 deceased patients, 4 are between the 30 to 40 age group, that is around 5% of their total deceased patient. And one thing we can clearly see from here, like from the age of 40 to 55, the number of patients that died out of 81 is around 55 or 56%. That is a huge percentage. That shows like if a patient has an age group from 40 to 55, then the chances of their death is higher. So we can do further analysis like what's the reason behind this. Like if a patient has 40 to 55 age group, then why they are dying, why they have died as much as compared to the other age group. Go to the next slide. So let's come to the year-wise analysis, and from here we can see like what's the impact of year, what's the influence of year on the patient's survival. So we have the year range like from 1958 to 1969-70. These ranges, in that ranges the operation had done, and I took the bar graph here to demonstrate the patient count by year wise, and we can clearly see in the initial year like 58 and 59 the number of patients are much higher, or we can see like the survival status for the deceased patient is decreased. So that means like patients treated in the later years have the higher survival rate, maybe due to the improved treatment methods. This we can consider. And another thing is, as I told earlier, like in between 1958 to 1959, the mortality rate are higher as compared to the other year. So we have different age, as I told, from 1958 to 1969. I calculated the recovery rate by year. Means some of the years that have a higher recovery rate and some of the years that have lower recovery rate. So you can clearly see from this bar graph like some of the years 1960, 1961, 1966 and 67 had a higher recovery rate, and almost 84% or higher than that. That shows the good recovery rate for that year, and many patients were successfully survived or treated properly at that year. But there is another point that we have to consider, like in the year 1962 and in the year 1965, the percentage is dropped significantly. You can see it's around 18 to 20% decrement as compared to the previous year, the percentage. So we have to check like what's the reason behind that percentage recovery rate or the survival rate is dropped significantly for some of the years in this age, in this year range. So if I talk about particularly 1965, so the number of lymph nodes are much higher. So there is a question that we have to consider, like what's the reason behind that. So let's do a deeper analysis of that, and starts from 1962, that what's the reason behind the significant drop in their survival rate. So I compared from the previous year for 1962, so we have to compare from the 1961. So this comparison distribution plot are showing us like what's the reason. So the red graph or the red bar is showing for the year 1962. So we can clearly see from here that the patient that came in that year have a higher lymph node 14, 20, 22 and 35, okay, as compared to the 1961. So we can say that in 1962 more patients had the lymph node that is greater than 10 as compared to the previous one. So that one reason can be, but we have to check like for the patient that have the lymph node more than 10 years. So did they survive or not? If they survived, then we can't consider that. But if they are not survived, then we can clearly say that the number of lymph node is responsible for the decrement in the recovery rate for the 1962 year. So I have took this table or took this matrix here. So we have to check for 14, 20, 22 and 35, that is greater than 10, and this is the number of nodes, this is the survival status. So the patient having 14 nodes didn't survive, 22 didn't survive and 32 35 also didn't survive. But the patient whose nodes was 20 was survived. So either they survived or not. So what's the reason, or we do further analysis, try to consider the age of that patient. If that age shows like patient was younger or older, what's that? So mean match is showing here the age of that patient. We can clearly see that the patient that have nodes are higher, 14, 22, 35 are older in their age. So age is also a factor that we have to consider, like the patient that was not survived had a higher age or the higher lymph nodes, or the patient had their operation in that particular year whose survival rate are not higher, or the mortality rate of that particular year is higher. So we can conclude to this point, the patient having the nodes more than 10 didn't survive due to the higher node count and age, except one with 20 nodes who survived due to their younger age. For that patient whose nodes was 20, that was survived, but we can see that patient age is 42, that we can consider younger as compared to the 57, 65 and 59. So that's the reason we can consider from this data. So similar type of trend or behavior we can see for the year 1965 also. Like you can see in 1965, some of the patients that came have the higher lymph nodes, 19, 20, 22 and 23. And same we can consider here that the patient except 22, all the patients and most of the patients we can say had not survived. And the age are also higher. So we can conclude that patients having more than 10 nodes didn't survive due to their higher nodes count, or their age are also higher. Except one, but that exception may be due to the other factors that are influencing the breast cancer. So this is our node-wise analysis, and as we have different number of patients, around 306 patients we have, in that there are different distribution in their nodes. The minimum nodes, or the patient that have very lowest node, we can say 0 nodes or no nodes, that patient, and the maximum node of the patient was 62. So I have done this decomposition tree, you can say. So for the patient who didn't have any nodes, 44% from the total of the patient that didn't have any nodes, and in that 86% were survived and 14% didn't survive. Increasing the number of nodes, like 5 or less than nodes, so 77% of the patients have that, and in that 80% survived and 20% didn't survive. If you consider 15 nodes, like the number of nodes were 15 and lower than that, so 92% of the patients that comes under this group, and in that 75% survived and 25% didn't survive. And the last, if the nodes were 15 or more, so 7% of the patients were come under this, and 55% survived and 45% didn't survive. So what's the conclusion from this? Like the number of nodes are increasing, so the survival rate is decreasing, like 86, 80, 75 and 55. Another way we can say that the number of nodes are increasing, then the mortality rate is also increasing from 14, 19, 24 and 45. So the number of nodes have a significant impact on the survival status of the patient. And here's a bar graph that is demonstrating another story, like the patient who had a lymph node from 0 to 5 are much higher. The patient count are much higher, as you can clearly see, like 236 patients out of 306. So that is a huge say. Another thing we can consider from this bar, like in that Chicago or the surrounding area, the patient that had came for the operation are very conscious for their treatment, because 0 to 5 we can consider is the early stage of the breast cancer. So that patient came in the early stage and did the screening and operation and so on. So that shows like the patient awareness is much higher in that region. So let's go to the next slide. Here I am comparing, or I want to see the correlation between the nodes and age of the patient. So this is a scatter plot. The blue one is showing the patient that was survived and red one that was not survived. So previously when I was doing the age-wise analysis, so there 40 to 55 of the patient, I want to show that. So here 40 to 55 age bracket have the higher mortality rate. So what's the reason? For that reason also I have considered that scatter plot. So you can consider from 40 to 55 means when the nodes are higher, the patient didn't survive. Another thing I am considering here, that most patients with more than 15 nodes and over, and the years or the age of the patient are 40, are survived, because I want to show one thing in the previous slide. If the nodes of the patient is greater than 15, so 55% of the patient are survived. So what's the reason, like if the patient had nodes 15 or higher, because the 15 number of nodes are not lower, but if a patient had that node and that didn't survive, so what's the reason? We have to check that also. For particular this reason, I have go deeper and wanted to check like what the reason behind that. So I came to this point, like if the patient had 15 nodes or 40 and the age of the patient are greater than 40, so you can see this, the year means the operational year of the patient were in that year that has a higher survival rate, and you can see like 1961, 62, 66 and 67 were the years that have the higher survival rate as compared to the other years. So that's the reason you can consider. I am concluding what I am saying. So 55% of the patients were survived whose age is 40 or higher, or the lymph node 15 or higher. So what's the reason? We have clearly seen that for that patient the operational year were in 1961, 62, 66 and 67. That year was a successful year for their survival rate. So right now I am concluding like whatever the exploratory data analysis I have performed with the help of Python, the different factors that are influencing for the survival state of the patient, like age, nodes and the years also. The first point that I want to conclude that the continuous improvement in treatment method over the year contributed to the better outcomes that we see. Like as we go higher in the years, operational years, the number of patients were decreasing and the survival rate were also increasing. So that means treatment method were improved accordingly to the year. And the second point that we have, if the patient have lymph node 5 or less, or the age were also less than 40, so we can consider like the survival rate of that patient is much higher as compared to the other. And the third point that we concluded that like the number of patients that have survived is due to some of the factors, either that have a lower lymph nodes or a younger in age, or the operation that had performed in that successful year, means the years that have the survival rate are higher as compared to the other years. So I am concluding. Hope you get all the insights, whatever I want to convey from this data, and I want to thank that you came to this point and watched complete video of mine regarding the presentation of the Haberman's data set. So it's all from me. Okay.